Hello, my name is Alex Greiman, and my project is on machine learning and ecosystem degradation. First, let's talk about anthropogenic activity, or more simply, human activity. Humans have caused massive changes to Earth's natural environment. We have altered the climate significantly due to burning fossil fuels and contributing to the greenhouse gas effect. We release contaminants into waterways and soils that will never be recovered or remediated, and we lose tens of millions of acres in forest every year, including critical habitat for many species. So what effect does this have on ecosystems? Well, ecosystems and biodiversity are declining at unprecedented rates. The 2022 Living Planet report reveals there has been an average of 69% decline in species populations since 1970. Also, at least 1 in 8 species are at risk of extinction within the relatively near future. So why are biodiversity and ecosystem function important? Well, biodiversity is essential for healthy and resilient ecosystems. And healthy ecosystems create the world as we know it. Ecosystems are a complicated, symbiotic thing where many different species and organisms work to create the ecosystem as we know it. The primary producers turn sunlight into usable forms of energy. Microorganisms break down organic matter into nutrients that plants can use to grow. Both plants and microorganisms can clean air and water. Pollinators can allow plants to reproduce. Small animals feed larger animals, which feed the apex predators, which when they die will go down to feed the smaller organisms again on the bottom of the food chain. Essentially, they all work together and they help create our environment as we know it. So that includes our food and water supplies and our atmosphere. So what am I trying to discover with this project? I want to discover connections between countries with positive and negative forest cover trends. I want to discover how populations have changed in a certain ecosystem to determine its resilience. And I want to see if a model can be trained to discern between certain headlines pertaining to biodiversity. So who will benefit from this stuff? Well, if I can discern what commonalities countries with certain forest cover trends have, we can figure out what works and doesn't work for promoting forest protection, therefore promoting habitat protection. Assessing the biodiversity trends in a certain population will give us insight into its resilience and allow for comparison to itself and other populations going forward, as well as retroactively. Okay, so here's the forest cover data that I used. Originally, it was just land cover and forest cover from 1990, 2000, 2010, and 2020 for all countries. I changed this to just be a percent change in forest cover per decade for each country. An example can be seen below. Yeah. So the data I used for a population of an ecosystem was a Swedish birds migratory data set. It was comprised of surveys on Swedish migratory birds from 1975 to 2023, and it contained around 90,000 data points. I converted it into transaction data. So for every sampling date, every survey date, I created a new transaction. And as part of that transaction, it was all species that were found that day. So an example can be seen of this on the right of one day. All these species were found on that day, and so that would be your transaction. Finally, I performed a news API query on headlines of articles with topics climate, biodiversity, and health. I performed 3 separate queries. I then count vectorized the headlines and labeled them. So if it was a biodiversity, I put a biodiversity label on it. And then I combine them all into what you see on the bottom right with a label and then the words that were used in the headline. Okay, so here are some results. I performed k-means clustering of countries based on tree cover changes. So the data's on the right in its clusters. You have three-dimensional data. I didn't perform PCA. I didn't reduce it at all. I think, well, here. So the green group had a massive, all countries as a part of the green group had a massive increase in forest area from 1990 to 2010. The teal group had a general increase in forest cover, or increase and decrease. And then the yellow and blue groups showed varying levels of decreasing forest cover. This has 4 clusters. I do think it could be valuable to cluster it in 2 or 3 as well. And I did that, but for this presentation, I'm just showing you the 4. For the green group specifically, there were only 4, but I think it's valuable to look at the similarities. I was curious if they would be similar in geographic location, but they were Cape Verde, Iceland, Kuwait, and Uruguay were the 4 countries as part of that green group. And so no seemingly obvious connection. I didn't make any obvious connection between the 4, but as I looked into it, Cape Verde, Iceland, and Kuwait all had dedicated restoration efforts, and clearly they paid off. You can see it in the data. They all had significant increases in forest cover. Uruguay did not have dedicated restoration efforts. However, they had an increase in forest cover due to large-scale tree plantations. And so they exhibit a similar trend, but for a different reason. I was curious if I could predict the continent of a country based on this tree cover trend. So I took away the country label and I replaced it with a continent label, and I trained the model on it and then tested it. And these are the testing results on the right, with the true label on the vertical axis and the predicted on the horizontal. The model did not work well. It showed an extreme bias towards predicting Oceania with an overall accuracy of 22%. This supports the claim that countries in a certain continent do not follow the same tree cover pattern. So it's not determined by geographical location, but rather a country's specific situation, policies, economy, etc. Okay, next I performed association role mining to look at associations of bird species found together throughout time. I performed association role mining on various time frames of the data set, so it's from 1975 to 2023. But here I'm going to show what I learned from comparing the top rules from 1975 to 1985. So I performed role mining on that decade, and then compare that to the most recent 8 years, so 2015 to 2023. So the top rules from 1975 to 1985, all of them stayed significant in the new decade. So all positive rules tested stayed that way. However, the strength and frequency of the rules did show variation. There were both positive increases in rules and negative increases, or negative changes. This suggests variation and changes in the population, assuming that would be from human activity. There are many associations in this data set. I mean, there were tons of rules. And so it was impossible for me to check them all and thoroughly look into them all. I really feel like I just scratched the surface. There's so much that could be done with this data set. It is possible that the strongest rules contain the most abundant species that would also be the most resilient and therefore the less likely to change. And that might be why I didn't see any huge changes in the strength of rules. So in the future, I would like to test the associations of birds that are maybe known to be more susceptible to endangerment. Okay. So here is identifying article topics based on the headlines. I used multinomial and Bernoulli naive Bayes just to compare the two. My multinomial naive Bayes model showed an overall accuracy of 77% with a slight bias towards health, but relatively low bias overall. The Bernoulli naive Bayes model showed a 65% overall accuracy and a quite significant bias towards predicting health. So I would say that one is not nearly as usable as the multinomial naive Bayes, and I'm not quite sure what the application of this model would be, but it was more just for curiosity's sake. Okay, so conclusions. From the tree cover data, because the tree cover data can be viewed as a direct result of anthropogenic activity and is also a proxy for habitat, we can use these results to see what leads to tree cover loss in terms of human activity. So evidence was found that dedicated restoration efforts do work. We can use this information to inform policymakers and persuade policymakers of the best way to protect our forests and habitats. And we also saw that it is important to be discerning when looking at the results of a model. If I was less discerning, I would have assumed that Uruguay had similar reasons and fit in with the other Cape Verde, Iceland, and Kuwait in terms of increase in forest cover. I would assume it was for the same reasons, but in reality, it was for the wrong reasons. It was because there were large-scale tree plantations, which doesn't necessarily increase habitat and promote biodiversity. If anything, it actually decreases biodiversity. Conclusions we can draw from the Swedish bird populations. The populations of Sweden's birds have stayed relatively constant despite anthropogenic activities. We did see changes suggesting it wasn't perfectly stable. However, there's much more analysis that could go into this data set. If I had more time, I would love to put into it. Specifically analyzing birds more susceptible to endangerment. Finally, what can we learn from this? Machine learning is a very powerful tool to assess how humans are impacting the Earth's biodiversity and ecosystems. And this information can then be used to inform policymakers how we can best protect our ecosystems going forward. Thank you.